So in this presentation, we're going to talk a little bit about the storage system in your memory. If you recall, the information processing model of memory says that there are three stages that are important to memory. We have the encoding stage, we have the storage stage, and then we have the retrieval stage. And so we're going to go over a new model of memory known as the Atkinson and Shiffrin model of memory. And for the most part, this model is going to be focusing on the different ways or places that memory is stored. So this is an overview of the Atkinson and Shiffrin model of memory. You can follow it sort of as a flow chart. You start with some sort of external event. So something happens that you're going to remember in some way. That external event then flows through three stages. Sometimes it goes through all three. Sometimes it just stops at the first or the second. But stage one is what we call sensory memory. So what we're going to do is we're going to just spend a minute or so talking about what sensory memory is, and then we're going to come back to this flow chart to continue through all the different stages. So sensory memory is defined on the screen for you right here. It is an immediate but very, very brief recording of sensory info in the memory system. Sensory memory is that entry point for the information that comes from your senses. We do have a couple of different types of sensory memory. The first kind that was really studied in detail was something known as iconic sensory memory, which was studied by a researcher known as George Sperling. And what Sperling discovered is that we do have this very brief recording of visual information. And it only lasts in our memory system for about 1 to 2 seconds before it's lost. But we do have a way that we actually record everything that we look at for a very, very, very brief instant. Most of it, obviously, we just lose. And that's the truth of most of sensory memory. Unless we're paying attention to it, we don't ever remember it past a second or two. But Sperling's research involved showing participants a series of letters flashed on a screen, much like you see here. With Sperling's research, what he would do is he would flash the letters for just like a millisecond, like a super brief amount of time, and then he'd play a different tone to tell his participants which ones he wanted them to recall. They'd already been conditioned to associate a high-sounding tone with the top row of letters, a medium tone with the middle letters, and then a low tone with the bottom letters. So they already knew what those tones meant. So he'd flash the letters for a very, very brief second, and then he'd play a tone. And he'd then ask them, what letters that tone represented. And what he found was that if he played the tone within a second or so after the letters are flashed, people could recall just those three letters. They couldn't really do more than that row. Their sensory memory wasn't that advanced. Advanced is maybe the wrong word. Their sensory memory didn't have that much capacity, but we do have the capacity to recall information for about 1 to 2 seconds from our visual system. Since Sperling's research, we found that we have a couple of different types of sensory memory. We probably have them actually for all of our different senses, but the ones that have been studied in the most detail will be visual-based and sound-based. Sperling studied this iconic or very brief visual memory, but we also now know we have something known as acoustic, sometimes in some textbooks known as echoic memory. And what's interesting is our sensory memory, our brief recall for acoustic information, is actually a little lengthier than iconic. Iconic is anywhere from 1 to 2 seconds. Acoustic, echoic goes a couple more. And the reason why we think that is because our communication system is very much sound-based. In order for us to figure out what someone's saying or communicating to us, we need to be able to compare the end of a sentence that we hear to the beginning. That's how you know if something's a question or a statement. If you ask a question, your voice goes up. If you're saying a statement, your voice goes down. And in order to hear that change, we need to be able to mentally compare. And so that's one of the reasons why, evolutionarily, we think acoustic information lasts just a smidgen longer than iconic information. Now, after information is very briefly recorded in what sometimes are called our sensory registers, clusters in that sensory memory, one of two things happens. Either we pay attention to that information and move it from sensory memory into the next stage, or the information is lost forever. And so if we look at this second stage of the Atkinson Shiffrin model of memory, we'll see that information, in order to be moved into the second stage of short-term working memory, in order for it to be encoded, we need to be paying attention. Attention is that process that moves information from sensory to short-term / working memory. So a little bit about what short-term memory is, and also a note, in the original Atkinson Shiffrin model of memory, short-term memory was the term that they used. STM is an area of memory which can hold a few items briefly. It's a holding area. That's what it is. It lasts more than 1 to 2 seconds of sensory memory, but it's a place where you really have to work in order to keep information there. Short-term memory is where information is either stored for just a couple minutes. Think someone just giving you their email address or their phone number, and you're just repeating it to yourself long enough to write it down somewhere or to store it in your phone. You're keeping that information in your short-term memory. Or information, you use it for like a little bit of time and then it's lost. Or you use it and then you revisit it a couple of times and you rehearse it and it moves on to the next stage. Now, in the model of memory I showed at the beginning of this presentation, we had short-term memory / working memory, and I included both of them on the slide. Working memory is an updated understanding of the short-term memory stage. Atkinson and Shiffrin's original model of memory only talked about short-term memory. However, updated information has shown us working memory is probably a better name for what happens here. To call this second stage working memory really emphasizes how active this stage of memory is. We have a lot of stuff that goes on in this stage, and if we journey back to that model, that flow chart that I had, we can see that whereas there's only one direction arrow from sensory to short-term working memory, we have bidirectional arrows going on here in between short-term working memory, we'll just use working memory right now, to the next stage, which is long-term memory. And so this is another reason why we call this stage working memory now, because you aren't just pushing information forward from working memory to long-term memory, although that is one of the things you're doing. You're also pulling information back out from long-term memory. That's how we encode and store information. In order to transition info from working to long-term, we make connections to stuff that we already know. We elaborate, we rehearse using information we've already encountered, and so there's this bi-directional flow of information that goes on here, and it's a very active place, and so that's why we call this stage working memory now. Now, the capacity of this second stage, the short-term working memory stage, is approximately 7 items. I say approximately because how we chunk information or how we cluster information can increase or decrease this. We think of 7 items. It could be just 7 digits, so 7 numbers by themselves. But it could also be increased by a little more if we cluster those digits. Think of how phone numbers are presented, for example. You don't have just a string of disconnected digits next to each other. You have chunks of information. And by chunking it in like an area code, for example, it makes it easier for you to recall it. Same with a license plate, a social security number. Those types of bits of information are going to be clustered or chunked in a way that can increase that like magical number 7 by just a little bit. Now, what I'll give you a chance to do in a second is an opportunity to test this out on yourself, see like how you can do if you attempt to use chunking or not chunking. So I'm going to show you a series of letters on the screen. What I want you to do is pause it, give yourself about 30 seconds just to look at the screen, maybe like 15. We'll make it 15. And then when the 15 seconds is up, look away from the screen and try to write down as many of these letters as you can recall. So on your mark, get set, go. Okay, so if you want to look at the letters you wrote down and then compare it to the screen, maybe see how you did. I assume that you did better if you attempted to chunk it in some way than just remember all of the letters. You could certainly try this on some of your family members. But what's interesting is that there is a way to get all of these letters recalled out of order. But if you rearrange the letters, you end up with these chunks. And when you look at these chunks, I could give you 15 seconds again to try to remember them. So if you want to pause and take another 15 seconds to remember these. And then you check your recall. I assume you did way better on this chunked version than the original just series of disconnected and meaningless chunks that maybe you created for yourself. And the reason for that is not only does chunking information increase our recall, but as we know, memory works based on meaning. So if you can have chunks that are also meaningful chunks, that's going to increase the odds that you recall it even more than just disconnected in terms of meaning chunks of information. All right, and then we finally reached the last stage of the Atkinson and Shiffrin model of memory, long-term memory storage. This is your relatively limitless, permanent storehouse of memory, and there's actually a lot more that goes into long-term memory. So I actually have another video about the different types of LTM that's going to go through all the different categories. But the thing to know about long-term memory for the Atkinson and Shiffrin model is that thus far we haven't encountered a limit for it. And in order for information to be stored in long-term memory, the best way possible, we really need to make connections and to engage in what we call elaborative rehearsal. That as we encounter new information, we go over it again and again and again, and we make connections to meaning, to things that are personally meaningful, to information that we already know the meaning of, in order to really encode it properly for long-term storage.